The new Qidi Max4 is a huge 3D printer packed with lots of features. So, is it the best large format 3D printer value? That's what we're going to find out in this video. Hi, I'm Ken of Wrist Innovations, and welcome to today's video where we will dig into the details of the new Qidi Max4 3D printer so you can make an informed decision on whether this printer is for you. I've organized the video into chapters listed in the description that will allow you to skip around the video depending on what is important to you. I want to thank Qidi for sending me the Max4. Okay, let's get started. First, let's cover parts quality. I printed parts on the Max4 using PLA, PETG, ABS, glass-filled ABS, and carbon-filled nylon, and I think you're going to be impressed with the results. Once I got the Max4 set up, I had to first print a preloaded design of a benchy in PLA, which turned out reasonably well. There was some stringing, but overall it was a reasonable print. Next, I printed a benchy design by Creative Tools in PLA using the Qidi Studio Slicer. This version of the benchy turned out great, with no stringing. Next, I printed this calibration test design by Gabax 3D on printables using PLA. For the Max4, the overhang test did successfully print all the way to 80 degrees. The various cylinder diameters measured 9.83 millimeters, 7.83 millimeters, 5.82 millimeters, and 3.91 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10 millimeters, 20.02 millimeters, and 29.96 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were only a few stringers on the part. Next, I printed a spiral vase design using PETG that was uploaded to printables by Max413049. However, the original design is by Big Bad Bison on Thingiverse.com. The Max4 part turned out beautiful. I really couldn't find any defects on this part. Okay, now let's step up our game with a more challenging material, ABS. ABS can be a challenge because it tends to easily warp when printing because it really needs a warm environment. I decided to print this vice grips tool design by 3dprintedhardware.com. I did use a brim and support because there is a lot of overhangs and some of the parts did not have much contact with the build plate. The nice thing about the Max4 is that the heated chamber was automatically activated since the slicer knew I was printing in ABS. I was really happy with the results from the Max4 because the vice grips turned out beautiful. The vice grips did not have any warping and it works really well. If you are working on a project and you need a 3D printed part, but you don't have a 3D printer, you can do that through the sponsor of today's video, PCBWay. They offer metal 3D printing in aluminum, stainless steel, and others, as well as plastic 3D printing in resin, PLA, PEEK, TPU, nylon, and others. You can go to PCBWay's website, upload your STL file, and they can make it and ship it right to your door. If your project needs other types of parts made, PCBWay can also provide PCBs and PCB assemblies. They also offer CNC machining, sheet metal fabrication, and injection molding in various metals and plastics. PCBWay is truly a one-stop shop for all your prototype needs, so please check them out. There is a link in the description below, and they will even provide you with a $5 welcome bonus. Thank you, PCBWay, for sponsoring today's video. Now, back to the show. Now, let's try glass-filled ABS. I decided to print this channel lock pliers tool designed by, again, 3dprintedhardware.com. I also used a brim because the parts are quite long and skinny. Just like with the ABS, for the glass-filled ABS, the Max4 automatically activated the heated chamber. I was also really happy with the results from the Max4 because the channel lock pliers turned out really great. The channel lock pliers did not have any warping and it works really well. Even though I'm not a big fan of multicolor printing due to the amount of wasted filament and how slow the prints take, since the Max4 has a multi-filament capabilities, I had to try a multicolor print. I printed this articulated Rexagon, which is a Trex plus Dragon Flexi by Pinky Wings on MakerWorld in 3 colors of PLA. Initially, I noticed that the purging from the black to white and from black to orange wasn't sufficient because the orange and white were contaminated with black filament. So I stopped the print. I adjusted the black to orange and the black to white purge amount from 90 millimeters cubed to 500 millimeters cubed. I'm sure I can fine-tune the amounts in the future, but I wanted to make sure that I printed a clean part, and these settings work. The Max4 took approximately 10 hours to print this part. The print turned out well, and all the joints easily moved. Okay, now let's try a really challenging material, carbon-filled nylon 12. Nylon is even more of a challenge than ABS because it is sensitive to humidity, and it tends to easily warp when printing because it also needs a really warm environment. The good news is that since the Max4 has the actively heated chamber, this will help increase our chances of success. Before printing, I dried the PA12CF at 90 degrees C in my Sunlu dryer for 2 hours because the Qidi box can only reach 65 degrees C. I decided to print these adjustable pliers designed by 3dprintedhardware.com. I also used a brim because the parts are quite long and skinny. Just like with the ABS and ABS glass build, the Max4 automatically activated the heated chamber. I was also really happy with the results from the Max4 because the pliers turned out great. The pliers did not have any warping and it works really well. So, to test the size of the Max4, I decided to 3D print my first cosplay helmet. I found this Iron Man helmet remixed by MercoBuilt 3D on MakerWorld. Due to the large print volume of the Max4, I consolidated the 4 build plates down to 2 build plates. It took approximately 19 hours to print all the parts. I taped all the parts together to see if I could fit my big head into the helmet before I spent the time gluing it all together, and I concluded that my fat head was just too big. I decided to scale the helmet to 120%, and I reprinted the helmet, which took approximately 28 hours this time. On this second try, a small feature of the helmet broke free from the build plate, but the helmet still printed fine other than this mishap. I also taped this helmet together, and I can get my head inside, but there is too much room. So just like Goldilocks and the Three Bears, I think if I reprinted the helmet to 110%, that should be just right. So, to summarize the parts quality section of this video, based on my initial experience with the Qidi Max4, it produces high-quality parts, including using engineering materials such as glass-filled ABS and carbon-filled nylon 12. Now, let's dive into the main features of the Max4. The Max4 is a very large 3D printer with overall printer dimensions of 558 millimeters wide by 578 millimeters deep by 612 millimeters high, not counting the Qidi box on top. The Max4 is quite heavy at 40 kilograms or 88 pounds. In fact, I bought this hydraulic cart from Harbor Freight to help me with getting the Max4 from the floor to my workbench height. The Max4 has a huge print volume of 390 millimeters by 390 millimeters by 340 millimeters, which is now the largest printer I own. Here's a comparison between the build plates of a 256 millimeter by 256 millimeter build plate and the Max4, and you can visually see the big difference. The Max4 is a fully enclosed CoreXY printer with rigid internal frames and a glass top and door. It has 1.5 GT custom belts, which are designed to reduce VFA, and it has a linear guide rail for the X-axis and 12mm diameter steel shafts for the Y-axis. The Max4 has a maximum hot end temperature of 370 degrees C, which is great for the higher temperature engineering materials. Qidi offers the 0.4mm diameter bimetal nozzle as standard. However, the 0.2mm, 0.6mm, and 0.8mm nozzles are available. The Max4 has a maximum build plate temperature of 120 degrees C, and Qidi claims it has a very uniform temperature distribution. The Max4 has a maximum speed of 800 millimeters per second and a maximum acceleration of 30,000 millimeters per second squared. It has a filament runout sensor, chamber fan with HEPA and carbon filter, and a nozzle wipe feature. The Max4 has a multicolor filament, multi-material capability when using the Qidi box, and it can take advantage of the Qidi RFID tags in the Qidi filament spools that allow the Qidi box to recognize the color and amount of specific materials on each spool. Each Qidi box unit can hold 4 spools of filament, and you can connect as many as 4 Qidi box units to the printer for a maximum of 16 colors. An added feature of the Qidi box is that it has a heater that allows you to dry your filaments with or without the printer printing parts, with a maximum temperature of 65 degrees C. The Max4 has an optional external extruder cooler unit that blows cool air directly on the extruder, and Qidi claims that this reduces nozzle clogs by 90%. The Max4 comes with a dual-side textured PEI build plate, and I noticed that I've had better adhesion with this new build plate versus previous Qidi model build plates. The Max4 works with the Qidi Studio Slicer, which is a fork of Orca slicer, and their phone app. The Max4 has an auto bed leveling, Z-axis offset, power loss recovery, and an internal LED light. The Max4 can print wirelessly using their slicer, and it can print in land mode. You can print the following filaments on the Max4: PLA, PETG, TPU, ABS, ASA, PC, and carbon-filled or glass-filled materials. The Max4 has a large 5-inch color touchscreen to communicate with the printer. The Max4 has a low frame rate, 1080p resolution camera that also provides spaghetti detection. The Max4 has 32 gigabyte eMMC memory, and you can transfer files using a USB drive. The one thing I will say about the Max4 is that it is a bit noisy, at least for printing PLA when I have the lid partially open and the door open and the external extruder coolers on. I was getting readings on my phone app in the 60 plus decibels range. It's quite easy to set up the Max4. The biggest challenge is to get the Max4 unboxed and onto your workbench due to the size and the weight of the printer. You may want to get a friend to help you with this. In my case, I bought a hydraulic table so I could do it myself. Once you remove the Max4 from the box, it's just a matter of removing the various foam packaging from the printer and the accessory box. First, remove the accessory box and foam from the printer through the top. Next, unscrew the screws holding the Qidi box inside the printer and remove the Qidi box from the top. Remove the screws from the Qidi box packaging support and remove it from the printer. Remove foam pieces from around the build plate. Unscrew the 4 screws that are holding the build plate platform to the printer. Remove the lead screw protective covers on both the left and right sides. Remove the foam and cardboard protecting the print head. Then connect the power cord and turn on the printer. Follow the screen prompts by choosing a language, geographic region, and set up your Wi-Fi. You can also bind the printer to the Qidi mobile app at this time. Next, you can follow the on-screen instructions to confirm you have completed all of the steps to set up the printer. After all of that, the printer will be ready to perform a self-check and calibration. Next, you can add the filament holder and load some of the filament into the printer. I also loaded the latest version of Qidi Studio Slicer software on my computer. Finally, I was ready to print my first print. If you have the Qidi box, then you can connect that to the printer as well. First, turn off the power to the printer. Unbox the Qidi box and place it on top of the printer. Remove the external filament holder and install the Qidi box hub. Attach the 4 Teflon tubes to the box hub and the other ends to the Qidi box. Attach the short Teflon tube from the box hub to the printer. Connect the signal cable to the Qidi box and to the printer, as well as the box hub signal cable to the box hub and the Qidi box. Attach the power cord to the Qidi box and turn on the Qidi box. Add filament to the Qidi box. To install the optional extruder cooler, remove the front cover of the tool head. Install the silicone tubing from the back of the printer through the cable tray and attach it to the fitting on the tool head. Replace the tool head cover. Install the signal cable to the printer in the back. Connect the power cord. You can activate the extruder cooler via the Qidi Studio Slicer as well as via the screen. Now let's talk about cost. At the making of this video, February 2026, the Qidi Max4 without the Qidi box unit is currently on sale for $1,049. normally $1,149. The Qidi Max4 with the Qidi box unit is on sale for $1,199, normally $1,299. In both cases, this includes the polar cooler in the price. As a comparison, the price of the Bambu Lab H2S without the AMS2 Pro is $1,249, and the H2S with the AMS2 Pro is $1,499. So the Qidi Max4 combo is $300 less than the Bambu Lab H2S combo. Let's go to my final summary and recommendations. Overall, I'm impressed with the quality of the prints I made on the Qidi Max4, including prints made from ABS and nylon. And I consider the print quality to be comparable to the quality from my Bambu Lab printers. Previously, there have been times in the past where I have had miscellaneous small issues with previous models of Qidi printers when I have received early versions for my evaluations. However, the Max 4 has been the smoothest evaluation I've had to date. Qidi had made several firmware changes to the Max 4, but due to my schedule, I did not initially start to evaluate the Max 4 until I had more time recently. So I went right to the latest firmware, and things just worked without any problems. The Max 4 is a huge printer with a monster print volume of 390 millimeters by 390 millimeters by 340 millimeters, which is by far the largest printer I own. It's also a quite heavy printer at 40 kilograms, so you need to be careful with moving it around your workspace. It also has some very fast maximum printing speed of 800 millimeters per second and acceleration of 30,000 millimeters per second squared. Qidi has made improvements to their Qidi box, and with the Max 4 having an actively heated chamber, a heated Qidi box, and a 370 degrees hot end, this printer can handle high-temperature engineering materials very easily. At a sale price of $1,199, the Max 4 is $300 cheaper than the Bambu Lab H2S, and the Max 4 has a larger print volume than the H2S. So the Max 4 is worth considering if you're planning to buy a large format printer in the near future. Bambu Lab has been at the top of the 3D printer market with their innovative product offering. However, I think Qidi has been slowly making progress with the evolution of their printers to provide a competitive alternative to Bambu Lab printers. What do you think? Which of these two printers would you buy? Let me know in the comments below. Also, if you're interested, I have an affiliate link for the Max 4 in the description below. If you would like to see my video titled New Anycubic Cobra X versus Bambu Lab A1, which is better? That link is here. If you'd like to see my video titled The New Qidi Q2 Combo, a worthy competitor? That link is here. Thanks for watching. Bye!